We've just learned about a .NET collection interface called iasync enumerable. Let's put that in historical context so that we can get a better idea of its intended use. .NET has three main collection interfaces. Each has a different purpose. IEnumerable was the first. It was intended to support iteration over collections using the for-each keyword. Then came iQueryable. It was introduced, along with LINQ, to support external data sources, such as databases. iQueryable collects a set of deferred operations, like select and where, so that they can be sent to the query provider and turned into an external query language. That query is executed when an immediate execution operator is called, such as toList or sum. Not to leave IEnumerable out, LINQ supported execution of queries on in-memory collections as well. When iQueryable is used, the deferred operators are not intended to be executed on the client, but with IEnumerable, they are. In fact, they're executed iteratively for every single object. When asynchronous programming was introduced to .NET, we were left with a bit of an imbalance. It was relatively easy to introduce async versions of the immediate execution operators that you can await, like toList async and sum async. But it was much more difficult to provide deferred operators that await you. And so we didn't get operators like select await and where await, at least not at first. Before that could happen, iasync enumerable was introduced. Iasync enumerable has more in common with IEnumerable than with iQueryable. Like IEnumerable, it has its own C# syntax in the form of async for each. And it doesn't support the deferred execution model the way that iQueryable does. In fact, LINQ doesn't even provide extension methods for iasync enumerable the way that it does for IEnumerable. And so now we have two gaps. .NET was missing async deferred operations like select await and where await, and it was missing LINQ operations altogether for iasync enumerable. The group that created reactive extensions for .NET had to solve these problems for observables, and so they applied their solutions to async enumerables. They published a NuGet package called system.linq.async that fills both of these gaps. It lets iasync enumerable participate in LINQ expressions, and it provides awaiting operators for more powerful composition. Now let's get back to Carlos and see how he uses this package in order to add a feature that would otherwise be very hard to implement. Carlos needs to add URLs to the feed results, but the domain service has no knowledge of the API. And so he needs to project the service results into new types. To do that, he needs LINQ methods, which are not natively implemented on iasync stream. And so he adds the system.linq.async NuGet package. And while this package gives him a lot of power, he's careful not to abuse it. Looking at the list shows method inside of the feed service, Carlos can see that it returns the show GUID, act GUID, and venue GUID. These GUIDs are part of the show info domain model. And the feed controller is directly returning those show info objects through the API. The problem is the consumers of that API want URLs and not GUIDs. A common convention for APIs is to return hypertext references, or hrefs. Carlos would really like for these properties to be hrefShow, hrefAct, and hrefVenue. But that would mean that he would have to produce those URLs from inside of this domain service. And it would be inappropriate for the domain layer to have that much information about the API. And so a better idea would be to have the shows feed transform those show info objects along the way into a different kind of object that does have an href. That data type would be a DTO, a data transfer object. It's best to keep DTO data types separate from the domain model. And so he creates a new class called showItem inside of the API layer. And this type has href properties instead of GUID properties. Now he just needs to project those shows into a collection of show items. Uh-oh, there's no select method. Remember, .NET did not provide LINQ methods to iasync enumerable out of the box. That came from a third party. To get those extension methods, he adds a reference to the NuGet package system.linq.async. And now he has select methods for days. In addition to the select and select many he's used to, he's got all these await variants as well. But for this, Carlos only needs the simple select method. He projects each show into a new show item and generates the appropriate URL. And then he can run the app to see the results. And now the results from the API call have hrefs instead of GUIDs. And he's still able to get that low time to first byte, 43 milliseconds as opposed to the 1.6 seconds that we started with. But what about all those new await methods? Wouldn't those be wonderful to use? Now those are very powerful, but they have to be used with extreme caution. If you need to call an async method on each result, you're probably falling victim to select n+1. You're performing one select for the results, and then an additional select for each of the n rows. And that could significantly impair your scalability. And so Carlos is happy with the solution just as it is. We looked at three kinds of collection interfaces: IEnumerable, iQueryable, and IAsyncEnumerable. These are very different from one another. Use each of them for their intended purpose. IEnumerable is for iteration. It was invented before asynchronous language constructs, so it is blocking. It's best used for objects in memory where non-blocking access is not important. iQueryable is for constructing queries. It was invented alongside LINQ, which has deferred and immediate operators. When asynchronous language constructs were added, only the immediate operators gained async versions. Prefer those versions to their blocking counterparts for greater scalability. IAsyncEnumerable is for iteration without blocking. When it was introduced, it did not offer LINQ support. That was added later by a third party. And so now, even though the LINQ operators work on all three of these types, they have very different meanings. Operators like select and where are only deferred when working with iQueryable. For the other two, they are executed on every object. Know the context in which you're using them and their impact on both latency and scalability. And finally, thank you so much for joining me and Carlos on this journey through Entity Framework Core 6 best practices. We've covered quite a lot, like structuring your code in order to control dependencies and to take advantage of the latest C# features. We've also seen how to build a CI/CD pipeline in order to securely deploy our databases to production. And we've seen how to eke out the best performance that Entity Framework Core 6 can offer. So please put these best practices to good use and let me know what awesome things you build.